Hello guys, in this video we are going to discuss the solution of the problem print anagrams together. So let us look at the problem statement. The problem statement says given an array of strings, return all group of strings that are anagrams. The groups must be created in order their appearance in the original array. Look at the sample cases for clarification. For instance, if this is the array which is given to us, then as we can see, act, cat and tag are anagram. Similarly, god and dog are anagram, because of which they have been clubbed together. And one more thing folks, since act comes first, because of which the anagrams related to act will be placed at first position, and then the anagrams related to other words will be placed at the subsequent position depending upon the order in which they have appeared in the array. So that's the problem statement folks. Now let us discuss the solution of this problem. The general idea behind solving this problem is, for a given word, first we have to check if it is an anagram. If it is an anagram, then we have to club the anagram words together, and towards the end we just have to return that clubbed words. So before discussing the solution of this problem, let us first discuss how we will be able to identify whether a word is an anagram or not. So for that, let us take two strings. Let us say the first string is act and the second string is tag. The way we will be able to identify whether this is an anagram or not, what we are going to do over here is we are going to sort both these strings. So after sorting the string S1, the string becomes act, and similarly after sorting string S2, S2 string also becomes act. Now as we can see over here, S1 and S2 string are equal, because of which they are anagram. Now let us say rather than given two words, we are given a list of words. So let us say the words which are given to us is this. And within these words, we need to find out whether they are anagram of each other or not. And the way we will be able to check whether they are anagram is applying the same principle, which is essentially we are going to sort each of the words of this array. So let us sort that. After sorting, this becomes act, this becomes DGO, similarly cat becomes ACT, dog becomes DGO, and tag becomes ACT. Now once we have sorted each of the words of the array, all we have to do is we have to compare each word against rest of the word in order to find out whether they are anagram of each other or not. Now in order to optimize our searching, what we are going to do is we are going to keep these sorted word in a dictionary. So let us see how in an optimal way we will be able to club anagrams together. So for this folks, what we are going to do is we are going to take a dictionary. So let us say this is the dictionary which we have. And similarly, let us take our result list. And this is a list of list. Now let us see how we will be able to club anagrams together. So the first character which we are observing over here is act. After sorting act, this becomes equals to act. To check whether act is an anagram, we are going to check our map. Since over here the dictionary is empty, because of which we are going to mark an entry of act in the dictionary, and the value associated to act will be 0. This 0 simply represents the size of this result array which we have. Since the result array is 0, because of which act has been set to 0. And after doing so, we are going to place act over here. Now let us proceed forward. The next word which we have is God. After sorting God, this becomes equals to DGO, and we are going to check whether DGO exists in map or not. In this case, DGO does not exist in map, so we are going to mark an entry of DGO over here, and the value over here will be equals to size of the result dictionary. So the size of the result dictionary is 1, so this 1 will come over here. And then as usual, at the first location, we are going to make an entry of God over here. Please note folks, in map we are storing sorted words, whereas in the result we are storing the word as it is. Now the next word which we have is cat. After sorting cat, this becomes equals to act, and we are going to check whether act exists in map or not. Now since act is an anagram, which simply means cat is an anagram. Now since cat is an anagram, we need to place cat to its appropriate location. And what is that appropriate location? Well, the appropriate location is given by this 0 over here. So we are going to place cat at the 0th position in the result dictionary. So cat will come over here. Similarly, the next character is dog. After sorting dogs becomes equals to DGO, then we are going to check whether DGO already exists in map. Since DGO already exists in map, because of which we realize that dog is an anagram. And where do we need to insert dog? Well, the position where we need to insert dog is 1th position. So we are going to come over here and we are going to insert dog at this position. Now the next word over here is TAC. After sorting tag, this becomes equals to act. And since act already exists in map, because of which the word TAC is an anagram. And the position where it is anagram with is 0th position. So over here we are going to insert it at the 0th position. And in this way we have populated our result array, and towards the end we just have to return the result array. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to club anagrams, and for this an array is given to us. So for this, let's have a dictionary with us, and let's also have a result array. Now we are going to iterate on each of the elements of the array. So for element in ARR, the first thing which we are going to do is we are going to sort this element. So let's have TMP equals to sorted element. Now since TMP is a list, now let us convert our list to string. So let's say S is equals to join TMP. So now the sorted word is there in the variable S, and let us check whether S is an anagram. If S is not an anagram, then this is a new string which we have obtained. So let us make an entry of S in our dictionary MP. So MP of S equals to, and what should be the value? Well, the value will be equals to len of result. Remember folks, from our previous discussion, the position where act has to be inserted was given by the length of result array, and that's exactly what we are doing over here. And after that, let us extend our result array. So let's post an empty element in the result array, and finally all we have to do is result of mp of s dot append the element, and towards the end we just have to return result. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here map is equals to dictionary, result is a list, and then we are iterating on the elements of the array. The first thing which we have done is we have sorted this element and we have kept that in a variable s. We are checking whether s is not an anagram. If s is not an anagram, then mp of s is equals to length of result, and then we are expanding our result array by 1, and then we are placing the element at mp of s position, and towards the end we are returning result. So that's the Python implementation, folks. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Map is there and the result array. We are iterating on the elements of the array, and the first thing which we have done is we have sorted the array, and then we are checking whether this is an anagram or not. If this is not an anagram, then mp of s equals to result dot size, and result we are expanding it by 1, and towards the end we are placing the element at its correct position, and towards the end we are returning result. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.